welcome again. This morning, we are going to finish up yesterday's session, which is sort of going around the world and checking out RGB usage in various places. And the one place we have not covered yet is Africa. And as you all know, we do have some African participants here, and we also have joining us online, Leanne Simpson, who works for COMET, but is in South Africa and has been in collaboration with some African colleagues to put together this presentation to talk about RGBs in Africa. So Leanne, whenever you're ready, take it away.
Fantastic. Thank you very much, Dan, and a very good morning to everyone. Yeah, as Dan said, my name is Leanne, and I've been really fortunate to be collaborating with a couple of people who are sitting in the room with you today. And we will all be working as a team during this presentation this morning. I will be presenting now, and then if you have any questions and so on, you've got some experts sitting amongst you there in the room. So, yep, it's a very good morning, and from South Africa, it's an afternoon. It looks like we've got some storms coming, so that's going to be a good change to our weather patterns, which have been dry and windy for a couple of weeks now. So when we talk about RGBs, RGBs are an incredibly and critically important part of forecasting on the African continent. And what we'll see today when we go through these presentations are some examples of the diversity we see in many countries in Africa and how the RGBs can individually help with particular situations and particular topographical features and so on. And so we're going to look at some information coming in from, I think we start off with Niger or Morocco, move on to Kenya, and end off with the South African input. So my collaborators for today's presentation, we have Yassine Belghani from Morocco, Hama Hamidou from Niger, Sarah Kimani from Kenya, Khulu Mkhlangu from South Africa, and I've put this together, and we'll have a look at some comparisons as we get to the end of the presentation as well. So starting off with Iamako, Niger, and as you saw on the map, that's towards West Africa, very dry desert part of the continent. And monitoring convection is an extremely important part of their day. I'm going to show a video clip and animation just of a case that happened just a few weeks ago in August, and the value of looking at the convective storms RGB during the daytime, where we can see some explosive development happening over West Africa and the formation of a squall line sort of moving through towards the latter parts of the day. And this is a really common effect for this time of year in Africa as well. And so as we move on to the evening time, RGB such as the nighttime microphysics to track these systems become very important as well. So convection can have devastating effects anywhere around the world, in particular areas where runoff can be quite extreme and large amounts of rain moving through as you get big squall lines developing, even MCCs and MCSs developing overnight and moving through. At least you can then track these systems throughout the heat of the day. As the sun goes down, you carry on with the nighttime microphysics to also watch them throughout the evening time. A very popular RGB that's being used on the continent at the moment is the tropical air mass RGB, which also helps to show deep convection. You'll see a couple of examples of this today. And this is that same event where we can start seeing the use of the water vapor imagery coming into the RGBs to understand what's happening at various levels of the atmosphere as well. And picking up where you have your deep convection, explosive convection happening, and being able to discern some of those cloud types and where you are seeing some overshooting tops essentially as well. By combining the water vapor imagery, even looking at it by itself, definitely adds a lot of value to the nowcasting aspect and forecasting aspect. So looking at the RGBs are still good, but there's still value in separating out some of those fields like the water vapor to see what is busy happening at the upper and even the mid levels of the atmosphere, and to understand how that works with the RGBs themselves. There's also the value of the satellite-derived products that come in, like precipitation rate, which can track with these systems. And so you can actually see and learn from what we're seeing in the RGBs, and to be able to then transfer that into some other data sets. So you can have a data integration and data fusion approach when we start looking at what is actually happening in the cloud and what's happening on the ground potentially from that as well, and understand how you can combine these data sets to be able to extract the most value from the forecast that you can. Something else that gets used quite a lot is for fog, is the nighttime microphysics for fog detection and tracking. And this is an example just off of Dakar in Senegal, where we can see here just in the west in the encircled area, a very, very faint area of fog that is busy developing overnight and into the early hours of the morning. And of course, once the sun comes up, we can switch into visible RGB mode as well. And so we can take examples like this and have a look at the day natural color RGB to see what happens to the fog as time goes on, and how it's encroaching just from being offshore and encroaching onto the coastline of the continent. But when we talk about West Africa, dust RGB is really what is used quite extensively. And quite sadly, you're going to have to go to Hama himself and ask him to show you this animation. There's something about the functionality that wouldn't transfer when he shared this particular animation with me. But what he's showing in those encircled areas there is that there was dust that was mobile, and then actually you could track it over a few days. There's like a 2 or 3 day period where you can actually track where the dust is going and how it slowly but surely moves along. So the dust RGB is an extremely valuable tool for that part of the world where there isn't a lot of other data to be able to detect features such as that, and so the dust RGB is really valuable to them. And with the monitoring of dust as well, the inclusion of some NWP data can also help with picking up where dust can be expected and how it is expected to move. So it's a combination of different data types. And of course, the NWP allows you to then have that initial verification of what is happening on the ground, and then you can forecast ahead and see what can potentially happen, and using your satellite image as your starting point. As we move slightly further north, up towards Morocco, we have got some input, again, quite a diverse country topographically and physically, desert areas along with mountainous areas, a coastal area, and so many different weather aspects that play a role here in Northwest Africa. So the 2 mountain ranges that are fairly close to the coast as well, and with those mountain ranges, you have got the development of convection that happens, and so the use of the convection RGB, the high resolution VIS, severe storms RGB, and cloud types, and using these to find the areas of intense updraft and strong convection is very, very useful. And of course, the color contrast helping to see your cloud types. The dust RGB and the 24-hour microphysics are also used quite extensively in Morocco, as well as the natural color RGB, which is a very popular one all over. The detection of dust is very important, not just over their country, but of course tracking it, coming in from Algeria and further west to see how it's coming through and how it can affect them. The distinction of cloud type, so finding your water clouds and ice clouds by using your microphysics RGB and your natural colors RGB also proves very, very useful. And here we can see some examples on the right-hand side of the convection RGB, how you can pick up the different convective cells, as well as using your 24-hour microphysics to help you out. Further applications of RGBs in Morocco would be fog detection, and again, that's similar to what we saw from Niger EMAC. So using the night microphysics RGB is a very, very popular approach, as well as the HRV fog during the day, and that's to be able to find your fog and low clouds as the day goes on. And as you can see, and when you start using the day natural color and the high-res vis fog detection, you can pick up those water clouds quite nicely, smooth water clouds in the morning hours. The use of the MS RGB comes in with Morocco, and we'll see it being used down towards southern Africa as well quite extensively. And that's generally with the synoptic scale, mesoscale systems, the synoptic scale systems moving through with your mid-latitude cyclones, your upper air jets, and those change in air masses coming through from the colder latitudes. And that really is very important to be able to find those jet streams, deformation zones, and to be able to identify your various mid and upper level cloud types. So from a Moroccan perspective, some of the challenging RGBs they have would be, they've listed the MPEF Fire product as being a product that they are struggling with because of the delay in anticipation, and the resolution factor seems to be fairly low. And expanding on that, we can just see here an example of their fire product, and perhaps Yassine can talk you through some more intricate details of that during the next couple of days. Finding fog can also be challenging to be able to distinguish between what is fog and what is low cloud. And we know this is very important from an aviation forecasting perspective. When you start seeing that low level water cloud, what are you actually seeing as it's based on the ground? Is it above the ground? What is that going to do to the visibility at airports? And so sometimes the resolution of that can also be a little bit tricky, particularly if you're trying to forecast for an area or a point value. But the integration of the RGBs with other data is very important. And so in Morocco, they do run the RGBs on site to display them. And what they do is they do apply them with other products. So the mixture and coming in with your SAF products, overlaying lightning, weather radar that gets used in conjunction with the RGBs. And these are all developed in-house and can be overlaid in visualization packages for their application. So here's an example of how they would overlay the MS RGB with some lightning detection, it looks like it, to be able to just verify where lightning has started and what is happening. Again, here as well, overlaying the day natural color RGB as well with what looks like some radar imagery to track the storms. Using the day convection, also with some lightning detection overlaid with that. So there are a lot of things that the RGBs can help with forecasting, and that would be the storm severity, what the development status is, and to be able to detect things such as your precipitation rates. You can look at your lightning intensity at the same time, cloud top temperatures. So this is all the information that they can derive from their visualization of the data by having a look at a point. They can actually get all that metadata coming up to be able to help them. So that is a really, really good tool to have. Being able to integrate your RGBs and to be able to compare those data sets with one another is really, really good for forecasting. And here's just an animation of them tracking as well. So here we got the RDT product, the rapidly developing thunderstorms, that is in combination here as well. Okay, and so some of the partners that Morocco work with, National Disaster Management, some of the ministries and other government organizations, and of course, National Agency for Fire and Forests, and your insurance agencies, which I think is a popular one for weather services to work with. So thank you very much, Yassine and the Moroccan delegates for helping us out with that information. Let's move down now to East Africa and to IMTR Kenya. And these slides come from Sarah Kimani. So Sarah's point that she gets to through the slides is very much about, it depends on where you are, and not just in Kenya, but in Africa and the world. Where are you, and what RGBs are you making use of for that for your particular need and for the need of your clients? And in West Central East Africa, Sarah's noting that it depends also on the hazard that is being forecast or being monitored. And convection, of course, forms a very large part of the hazards that are experienced, particularly over Central Africa as well. So being able to seek information on cloud top temperatures, development, movement, as well as the severity of storms is very important. So here are some examples of some useful RGBs for East Africa, and the day microphysics comes up. Sarah, I've got to tell you, day microphysics is one of my favorites, to be able to see cloud type, cloud phase, and you know, the evolution of some of these systems. I find it to be quite a useful RGB to use during the daytime. Also using precipitation rate at the ground, so using those satellite-derived products again to be able to see what is happening, particularly in the storms that are developing. The detection of low cloud and fog again comes up as something that's really important. So this is another, the third country that is saying low cloud and fog is important. The use of the nighttime microphysics, the use of the day microphysics again for the RGBs, and the severe storms for convection. You can see the convective cells popping up over Central Africa as well. The tropical air mass RGB coming through as another good useful RGB to see what those air masses are, to start detecting what's happening with those deep precipitating clouds and the development of the convective systems. Precipitation rate across the continent, again, another important factor, satellite-derived product to be making use of. And using the dust RGB. So the dust RGB can be used for a couple of instances, not only just for dust, but of course it does also help with some detection of some clouds if need be. So what are the most useful ones that have been listed for East Africa? Again, it depends on the hazards and the use of, starting off with the use of just your single channels, your IR 10.8 and high-res vis. So the general practice at the moment is that RGBs are used in research and so on. And why are the forecasters not comfortable using them or using them all the time? Does the challenge come in with the interpretation of the RGB? Is it just that your routine does not include the RGBs at this point? Or is it not applicable to what is happening? Can you answer the questions quickly and be able to give a valuable forecast just using your single channels? And also, again, it comes to the forecaster comfort level and confidence in using these RGBs. And of course, that then comes into our world of training. And how do we help forecasters to be able to derive and to extract the most value out of the RGBs? So the RGBs in East Africa allow the forecasters to carry out cloud analysis, as well as to monitor areas of fog and convection, to determine the cloud top temperatures, and to monitor the movement of your convective systems, including thunderstorms, MCSs, and so on. Forecasters can also nowcast if they are using a combination of other data types to be able to track what the storms are doing. So if we are integrating your data types with your RGBs, depending on what you're using, I'm assuming that sort of we're looking at a view here. Sarah's going to have to help me out with what the parameter is that is being overlaid, but it does look like to be some kind of moisture or temperature-based parameter, but I think you can follow up with her after this. So what is up next? What does East Africa say is the next step in RGBs to improve or strengthen the utilization? And of course, the training of forecasters to address those challenges and to strengthen the visibility, maybe the usability, the availability of RGBs, to share success stories of using the RGBs in the forecast as well. And but not just training on interpretation, but also the technical aspects, the scientific aspects. Where does it come from? What are we looking at? And so finally, let's move down to the southern part of the continent and see how South Africa and the South African Weather Service are using the RGBs in Southern Africa. So a very, very popular one would be Day Natural Colors RGB to help with your cloud type and cloud phase. The forecasters note that this RGB in particular is very easy and to interpret, and they're used to using it. It's ideal for identifying convective development and helps with the cloud type development, as well as between your land features. And we can use it to depict snow as well once it falls, because of the ability to be able to discern the ice on the ground. Benefits of the day microphysics would be to distinguish between your cloud phase and cloud types, as well as being able to depict snow on the ground and to be able to see wildfires and the breakout of fires. So fire comes up as a common theme between SAWS as well as Morocco. The convective storms, RGB, again, monitoring of the development and movement of thunderstorms, and to be able, again, to see those cloud top temperatures and to be able to see your ice phase at the top of the storm cells. The MS RGB is still very popular and used quite a lot down in South Africa and dealing with the approaching mid-latitude systems out of the Southwest Atlantic. And so identifying and tracking those systems 24 hours a day overnight gives good continuity to the forecasters and good confidence in tracking those systems and being able to use the potential vorticity visualization to also see things like cyclogenesis and upper air low pressure systems forming and so on. And so the Weather Service and Hulu Mthlangu says that what they say is that they know that the RGBs have their limitations, and so it's important to understand what the benefits are of each of the RGBs and to apply them in an applicable manner. So the South African Weather Service integrates satellite imagery and RGBs with a lot of other data sources. Again, there's the use of the RDT, or the Rapidly Developing Thunderstorms product, up in the top left-hand side. We also have the Flash Flood Guidance System, which assimilates satellite data to be able to forecast the precipitation rates that are coming, as well as down in the bottom left-hand corner, hail trackers and storm tracking that can be done. And then in the bottom right-hand side in block D, the storm tracker just zoomed in that we can use that information as well. So the integration of imagery and creating some derived products can really help. So what I did is I had a look at the 4 countries and the 4 contributions that were sent, and there were some common themes that came up, and those are presented in the central column here: convection, fog detection, dust detection. So even though it's not mentioned in countries like South Africa does need to do dust detection at times, particularly through Namibia, Botswana, and the western part of South Africa, which is very arid and a desert area. And often the use of the dust RGB is quite important. And in fact, we've run into some difficulties at times because it's not an RGB that is readily available. It wasn't at one point where it actually hadn't been set up properly that it was quickly available. We had to do it because of a dust event to be able to track it, because it wasn't seen as a necessity when we first got the MSG suite of products. And so it has turned out that it does get used fairly often to track dust that's moving off of the coast from Namibia and the South African west coast as well. The MS RGB, as well as the tropical MS RGB, these are very common and useful RGBs being used for location and movement of systems, even finding of convection. And then point number 5, the data fusion, the overlays, the remote sensing use, the data assimilation into other products. Is something that is being done in many areas on the continent to be able to extract information and to make the forecasters process a little bit more efficient and to be able to add more and more value to the communication of the forecast and what you can tell your clients. The satellite-derived products are obviously used quite extensively as well in most of the countries. So what are the benefits and challenges that we're seeing? Benefits on the left-hand side: people are liking color contrast, people like the color associations and the interpretation thereof that can make the job and the sequence quite easy to do. Being able to track your storm's development, intensity, and movement is very important, particularly with the lack of radar. So the lack of radar on the African continent is quite a big thing, as well as a lightning detection systems. So without those real-time data sources, the tracking of convection and thunderstorms via satellite or satellite-derived products becomes essential and crucial to nowcasting, to disaster management, to hazards, and the forecasting thereof. Being able to identify cloud phase type and height comes in because that links into fog, It links into whether you're seeing low-level convection or mid-level convection happening. Is it altocumulus? Is it cumulus? What are you busy seeing? So those aspects are very important. And then the nowcasting piece comes in, because being able to be monitoring the real-time weather and short-term changes and being able to communicate that to the people who need it are very, very important. So countries like Morocco and South Africa that do have radar, lightning detection, those kind of data sets work really well together in nowcasting. But in other countries in Africa, where satellite becomes the premium product and data source that is being used for that, it becomes essential. Some of the challenges being seen: spatial and temporal resolution are coming out as maybe an issue, or there's a need there for it to be improved so that the forecasts and the products being produced can be improved. The low cloud or fog, RGB, the interpretation thereof. Are we seeing stratus or are we seeing fog? How thick is the fog? Fog density, is it thickening? Is it thinning out? Are there ways that we can start getting more information like that? Sometimes sort of pre-fire environment, maybe pre-fog environment as well. What can we anticipate from the clear air return? So what can we see from the ground? What can we see in the air masses that can maybe give us some kind of clue as to what could happen in the short term in those areas, particularly with fog development, maybe fire development, convective development could be very important. Sometimes the RGBs are not applicable to all areas. So it may not be applicable to be using the convective storms RGB over the western part of South Africa, Namibia, up towards Angola, on that coastal belt where you have a cold ocean current moving, where there's very, very little convection that comes from the ocean. Often it happens more over the interior of the continent. And so sometimes those countries won't really be using that RGB in that area. Sometimes you'll find that the fog detection isn't being used in other areas either. So it's not one package that fits all. Each country, each region in the country has their own particular physical and topographical needs for those RGBs. The interpretation in general, I think, has always been a need or a challenge since, I think, what has it been, since 2005, 2006, when we got the MSG suite of information. The interpretation of the various RGBs has been tricky, particularly for new forecasters coming in, where there are forecasters who've been using these systems for quite a while and they're quite confident and comfortable with what they use. And so sometimes particular forecasting officers stick to tried and tested RGBs and maybe don't expand their knowledge. And as Sarah was saying, from what happens in Kenya, maybe understanding some of those technical aspects of the RGB can help with that understanding and interpretation. So what questions should we be asking, just to wrap this up, about the RGBs? Start thinking about RGBs impact-based forecasting. How should these be working together? Can they work together? How do we make them work together? Why is it important to be able to move into that kind of framework? Are we effectively integrating our NWP with RGBs? We have to admit that NWP developments and enhancements in the science and technology, as well as now satellite technology, is taking forecasting to a different level. And are we being able to integrate or fuse these two data types effectively to be able to be using them in combination and to be able to harness the most we can out of it? Do we understand the physical and dynamical atmosphere? Do we understand the physics and dynamics of the NWP? And can we put those two things together to be able to grasp as much as we can? How are we going to optimize the MTG data and visualization? That's the next generation of satellite that will be available to Africa. I think we can start counting it in months now. Probably still a year, but we can bring it down to 2 months. I think it's getting really exciting with the launch of MTG and what we can expect to see and experience. And then, of course, we can't forget about the training needs, but we've got to think of how do we address them? What is the most effective way to be training the use of RGBs, the interpretation of RGBs, the understanding and the potential integration of RGBs into our forecasting processes? And that is my presentation from Africa, literally, and my African partners sitting in the States. Thank you very much for your attention. Thank you for contributions from Sarah, Hama, Yassine, and Hulu. I really do appreciate it. And yep, if you have any questions, please go ahead. And my colleagues that are on the floor can help you out with some of those answers as well.
Thank you, Leanne, for that very nice presentation. Let's open the floor for any questions or comments. I'll start. You mentioned the lack of radar, and I personally don't have a really good feel for the distribution of existing radars in Africa. I imagine it varies, where some countries may have one or more and some fewer or none. Can you or someone speak a little bit more about the availability of surface-based radar throughout the continent?
Yeah, sure. Perfect. In South Africa, the radar network doesn't have full coverage over the country. I think at this point, we're probably up to about 8 or 9 functional radar of various generations. Not all have Doppler capability. And so there is the coverage, but there's a lot of downtime as well because of aging infrastructure. And so South Africa has radar coverage, and Morocco has radar coverage, and perhaps Yassine can come in there to just expand a little bit on that. But other than that, I'm not confident as to any other countries that have surface-based radar at this point. It's possible that Egypt might have, but I'm not entirely sure. Yassine, in the room, perhaps you could expand on Morocco's radar network.
Hello, Leanne. I think we are the same like Leanne. We have a network of 6 weather radar, but we are in the process of renewing them in this period. Almost it's not work.
Well, what I can add is that in some few countries, we have radars only at the international airports, and that is mainly for aeronautical purposes. So most of the countries, they don't have networks, but there are some few countries in Northern Africa, countries like Algeria, Morocco, Tunisia, and Egypt, who has some radar networks. And then I think in Eastern Africa also, there are some countries, maybe Sarah will talk more about that. But in general, the radar observations is really very, 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 very limited. There is, for most countries, there's not even radar. And in sub-Saharan Africa, where you have radar is only at the airport. And there are only some few countries. Thank you.
Yeah, thank you so much. So I echo the same sentiments. There's no good coverage of radars in Africa, and in Eastern Africa especially. For example, in Kenya, they installed radars very many years ago, but they've never been operationalized. That has to do with resources, of course. And then I think also Rwanda may have radar. Yeah, but basically they're non-existent in East Africa. Oh yeah, I hear Tanzania has some radars.
Yeah, thank you for that. I'm asking, of course, because I mean, as Leanne pointed out, it sort of underscores the importance of the satellite observations to fill in those gaps. Here's Yassine again.
I can add to the speech of Hama, can add that most of Morocco radars are present to cover the mountains, the Atlas Mountains, also the Rif Mountains.
Okay, Mark.
Yeah, 2 thoughts. There's a group in, hey Leanne, by the way, really nice to see you. There's a group in Switzerland, a Finnish guy in Switzerland who's been doing some studies using machine learning on can you predict radar given the imager data and the lightning imager. He's basically trying to work out how much information there is in Europe in LI. But of course, in Africa, you can do the opposite thing of how much information are you missing by not having the radar. He might be worth finding out. We need to get you the contact details to pass that study on. And the other thought while you were presenting, just in terms of people learning how to use this stuff, the ASMET team meeting, so this is the group of Africa trainers who get together, is coming up. And I wonder if the the quick guides and things kind of needs to be on that agenda. Okay, Sarah's nodding, she's in charge, so it's going to be on the agenda. That's cool.
On your, oh, go ahead, Bernie, and then I have a comment.
Yeah, this is Bernie, and a comment on, in terms of what Mark just mentioned, you know, the level of training. And this is something that I know I've been thinking about and talking about for a number of years. You know, when you have someone who's more of a novice to RGBs, what do you teach them? And then as they learn more, or as they want to understand more, those are the people we want to reach out to even more to make sure they have the tools to help them better understand the RGBs. And then perhaps we can, so I'd be interested in hearing what is the agenda for your ASMET trainers. And we've had some ideas of, you know, what we've been presenting at some of our workshops for, say, basic versus advanced, and so on and so forth. Because I see that, you know, just making it a little bit more easier for them to understand. And that's where some of the discussions, I think, even about some of the standards, so that we don't have to figure out what is this RGB doing. I mean, there's a standard there and how to interpret it, and not have to spend extra time trying to figure out what the recipe is saying.
Just a quick follow-up, Mark, you mentioned the machine learning project, trying to predict radar. There is a similar effort which has been done here at CIRA by a guy named Kyle Hilburn. He's not actually in the room, but he's in the office nearby, where he's doing essentially that. He's used machine learning to use ABI channels, a select number of channels, as well as GLM lightning to predict the radar. And it works pretty well. But there's a paper, I can send you the link, and perhaps your colleague already has seen this paper, because anyway, I'll share that in case it would be helpful.
So as a follow-on to that, Dan, do you know about, because I know that Chris Slocum was working on something to maybe that's because it's more JPSS, satellite imagery to simulate microwave?
Yeah, so I think, so the idea here is microwave imagery is used by itself in some cases, and I think his focus was mainly on the tropics. So taking a look at you know, the structure around tropical cyclones, and of course the downside of microwave imagery is you only get a few passes a day, and it may or may not hit your storm, and et cetera. So Chris, his project involved exactly what Bernie said, is sort of using ABI to try to sort of predict what the microwave may tell you. And it works pretty well, actually, surprisingly so, because the limitation of these infrared imagers is you can't see beneath the cloud deck, and you can with microwave. So there's fundamentally missing information below the top level of clouds in the infrared data, but somehow the machine learning is able to pull out at least some of that information.
Yeah, just a quick comment. Yesterday I mentioned the ocean color community has their own view on the ocean color RGB, which is in our case true color RGB. I've learned in the meantime talking to experts, and I'm just adding to what Dan was saying. They have the selection of the channels from the polar orbiters that kind of suit their applications. And then they use the geostationary to advance this in time. I think machine learning as well is included there, but it works very, very well, similar to microwave.
Here's another question for, I guess, Leanne and our representatives from Africa. Of course, FCI going to be launching soon, on board MTG soon. And I know, Leanne, you mentioned one of the challenges is, in fact, there it is in the top right, the spatial temporal resolution. I guess my question is, what aspect of FCI are the folks in Africa most excited about? You know, obviously spatial temporal resolution is one thing, but you know, adding some channels as well. Can you or someone speak to that?
Yeah, I can give it a quick start, and then I think we'll hand it over to the users on the ground. But yeah, I do believe that the inclusion of some of the near infrared channels would start bringing in more capability, particularly around fire detection, which is an issue all over the place. I think, so those advancements in there and sort of expansion on some of the water vapor capabilities as well. So, higher resolution viz is always good, and the inclusion of those into the RGBs. The nice thing is that a lot of the channels obviously would look the same, so the learning of the FCI wouldn't be as steep as when we moved over to MSG. And so, hopefully the usability and the inclusion of using the new channels, the benefits that we can harness out of that can really be the focus of training going forward, that it doesn't have to be on these are whole new RGBs and this is how you do it. This can be, here's how we have enhanced your existing RGBs and here's a few new products that you can add into your basket. But perhaps I can hand over to Sarah in that sense to give us more info about the users on the ground and maybe some of the conversations that have been happening in the Africa user forums, as well as the RIDEG teams and the ASMED team itself.
Thank you, Leanne. And yes, we are very, very much excited for the launch. And discussions have been had, as you've said, in the RIDEG meetings and also amongst the African trainers. And we're focusing on actually creating, developing the capacity in the use of this of the new products that are coming up. So we are very, very excited, especially on the fire products. We'll be able to track, because for example, in Kenya, we have a lot of fires which we're not able to monitor. So what we get is a lot of distractions and even a lot of lives. So for us to be able to do that is going to be very, very interesting and very good for the nation, and also of course for the whole region. So we're pretty much excited about that. And in the RIDEG meetings, of course, we do discuss the implementation of the softwares. So we're going to look at the training so as to be able to allow forecasters in the region to be ready to use the data once it is available on the ground in their forecasting stations. So we're looking forward to the implementation of the new POMA stations so that we are able to we are ready to uptake the new data as it comes in. So yeah, so we're very much excited about the whole aspect of MTG. Thank you.
Thank you. Yeah, fire detection is, sometimes we get asked the question, what were you most surprised about or pleased by with when NOAA upgraded to the ABI on GOES 16? And of course it depends who you ask, but one very common answer is fire detection, is improvement of that 3.9 micrometer resolution from 4 kilometers to 2 kilometers. It really makes a tremendous difference in seeing some of those smaller fires when they're, before they get too large and get out of control. And of course, I believe FCI is going to go even higher resolution to 1 kilometer. Isn't that correct? Yeah, Yvonne is nodding his head. So yeah, that will make a really big difference. Because Severi is 4 kilometers, yes? It's in the 3. It's 3. Okay, so it's sort of in between. But still, that'll be a massive improvement in the detection.
So I have a related question. I'm wondering, because how many EU METCAST stations does most of Africa use? And the reason I'm asking is because we have the GOES read broadcast now, and then we have a GeoNetcast, which is more for South America. And the way it's, because of limited bandwidth with the rebroadcast, the half kilometer GOES does not go across the broadcast. It's 1 kilometer for the 0.64 channel. And then I think it's not even all the times, so there, instead of having every 10 minutes for the full disc, it's there's only it skips one of them. So I was wondering, do you get all the full resolution with EU METCAST for Africa?
So the reason for the little thing, so Sarah is chair of the WMO RA1 Data Dissemination Experts Group. And this is so EUMETSAT is a satellite data provider. We've been working with this group to address exactly this issue of the bandwidth challenge. So we've reached I'm reaching for the best diplomatic words I can find. We've reached a compromise given the constraints that are available. So given the constraints, we've gone, okay, what is the minimum of everything we can put together that fits inside the bandwidth? We've been recorded. It's not satisfactory. If you say, is this good enough to do the job? The answer is kind of not really yes. But this is the best compromise we can reach given the bandwidth constraint, because the bandwidth costs money. So we've had to put in temporal constraints. We've done cutouts on some of the data. When we hit commissioning, we're going to see what this actually looks like, see what the RGBs, so we're sending some RGBs, some actual data so that people can build some of the other RGBs locally. We're also going to have to look at, are there some centers who want to work within, say, regional groupings to run nowcasting SAF software environments and then share that within the regional groupings, because there are regional specialized meteorological centers. So this is going to be quite tricky. As a satellite provider, our role is to provide as much data as we can, and it's up to the continent to, fight with us to make that bigger and see how we can solve problems.
Yeah, and I'm not sure if Marcial was here for the whole question. In South America, Central and South America, we're doing similar things with, if you can't get it all through GeoNetcasts, although it's beneficial to you, how can you supplement it with, even through the internet or ground-based data? And are you going to talk about that a little bit tomorrow morning? Yeah, okay.
Any problems getting old? The other thing we have is a thing called UMetcast terrestrial, which is a multicast feed via the academic network, so via GEONT. And so that gives people the full access to the whole data set. So if weather services can get connected to it, which is a big if in a lot of countries, not everyone can, then they can get access to the full data feed. And that's a little bit of what the future is.
Yeah, and I can't remember if looking at the list, if anyone was here from the Asia Pacific region, because they may have similar challenges in terms of access for small island countries. And I mainly bring that up. I mean, we are aware of some of these problems, but not everybody else is. And so these are some of the extra challenges that some areas of the globe face. And that was one of the main reasons why I'm pointing them out. And if anybody has some good solutions to them, we're interested in hearing them as well.
Thank you very much, Arian from Indonesia. I have some question for Lian about the RGB that Africa have a tropical region, same with Indonesia. So that based on your presentation, are you using the standard RGB for all products, or you have to tuning to a tropical region? Because in Africa, we know the northern Africa, maybe in the Pacific, the tropical region. So that is my point. And short comments for you. I'm interested with your statement about the impact-based forecast. Impact-based forecasting, what the WMO initiative that very, very good. That this is related to the RGB, that the signal, it's very clear that we have to thinking about that for our discuss, because very clear the RGB can give more for us, especially for satellite and for the impact-based forecast. Thank you.
Great, thank you for the question and comment. Absolutely. So just on the IBF first, the WMO is quite focused on the CAP rollout, the Common Alert Protocol, and the communication between countries with alerting and impact-based forecasting in particular around what the weather will do and not what the weather will be. And the conversations around RGBs and satellite imagery have been a lot about nowcasting and interpretation, but I think we're ready to take that next step, particularly as the spatial temporal resolution increases with the FCI instrument. we can start having those applications with impact-based, hazard-related, can be even further enhanced than what they are at the moment. And it becomes very, very important. And as Mark alluded to a little bit earlier about there being centers in Africa that are processing data and sharing to neighbors, where if a country is processing certain products from the satellite and creating derived products and overlays and combinations, that they share them with neighbors, which can help with continuity of forecasting, not just of systems and your general forecasting, but also of hazards. And so that impact-based forecasting can come in quite nicely there. When it comes to the tropical air mass RGB, I will need to defer to one of my colleagues, but the way I understand it is that it is, as you say, it's kind of tuned for the warmer climates to be able to pick up sort of the deeper convection going up higher into the atmosphere. But perhaps someone like Hama or Sarah Yassine can come in there. I think it's one of the newer inclusions into what is available from the RGB selections.
Okay, thank you very much, Leanne. For other RGBs, not the air mass, the tropical air mass RGB, we use the standard tuning recommended by WMO. But what we found that at times the color interpretation will be very different depending on whether you are in the tropics or in the extratropics. So what we try to do is really to relate the color interpretation to what is seen over the tropic. Like when I take the case of fog, when you look at the fog in the extratropics, it looks greenish, but when you come to the tropics, it looks like a kind of cyan color. So we have to adapt those colors interpretation to our in region. For the air mass RGB, it's a special tuning for the tropical area, and it uses the same recipes as the general air mass RGB, but the gamma corrections and then the intervals and the gamma corrections are not the same as in the ordinary. So that is where the changes are, but it's the same combination, channel combination like the ordinary air mass RGB. And initially, this RGB was called overshooting tops because in the tropics at night, we will have it. I mean, we have a very strong diurnal cycle in the tropics of convection, and our convection are most mature during daytime. I mean, during nighttime. So most of the heavy rains and the strong convections occurs during the night. And during the night, there is no much satellite product to really follow the deep convection. And the idea came that maybe we can use those combinations to follow the deep convection, and that's why initially it was called the overshooting tops RGB. But later on, the name changed to tropical air mass. It is using the same combination as the air mass GB. So that's what I can say regarding this question. I don't know whether. Okay.
Thank you, Hama. Yeah, Emily.
That's kind of a good point, maybe for the open spaces. You know, if there's so much focus on the tropical RGBs, you know, what are the best practices? How far outside of the tropics can you use them? Do you need to process the tropical RGB on the full disk? If you do, you know, how does that change if somebody does use it? Change the interpretation. So there's a lot there to discuss that might be really valuable during open spaces.
Speaking of open spaces, it's time. So Leanne, thank you. Let's give her a hand one more time.